Figures 10.15 and 10.16, friends can access private members of a class. So far, each of the classes that we've been looking at has had some amount of private data. And one of the key points we've been emphasizing is the fact that that data is encapsulated inside the class and can be accessed only by the member functions that are also defined within that same class. Well, there is an exception to this rule, and the concept is called a friend of the class. You can have individual functions that are declared to be friends of a class. You can also have entire other classes worth of functions that are declared to be friends of a class, and anything that is declared to be a friend of a given class is allowed to access that class's private data, provided that the friend function has a handle to an object of the class that contains the private data. So for the purpose of this example, we have a mechanical example to introduce this concept of friendship, and we'll begin at the top of this file with the class called count, which has just one private piece of data called x. In its public interface, I have a constructor which is using a member initializer list to initialize the data member x to the value 0. The empty body of the constructor is empty because of the fact that the initialization's been performed in the member initializer list, but the curly braces are still required on the constructor body. We also have a print function that will display the value of x. Now you notice we don't provide any kind of function for changing the value of x via the public interface of class count. However, back up at the top of the class we have what is known as a friend function declaration. The declaration is just a function prototype for some other function in this program that is not part of this class. And in this case, it's a global function called setX, which is defined down here starting at line 30, that receives a reference to a count object and an integer as its argument. And what it's going to do is take that integer and place it into the count object, and we'll see the implementation of that in just a moment. Now, the key piece here is the friend keyword. The designer of class count, me, said that setX is now declared to be a friend of this class. And basically, a friend of a class is something that's considered to be kind of tightly bound to that class, and therefore will treat the data of the class just like member functions treat the data, and that means making sure that the data remains valid as well. Now, this concept is used very frequently, in particular with operator overloading, because there's certain types of operator functions that we'll define that have to be defined as non-member functions of the class, and because they're so tightly coupled with the class that they're being defined for, such overloaded operator functions are often defined to be friends so they can directly access the data of the corresponding objects of the class. So we'll talk more about that concept when we get to operator overloading. Here we just want to demonstrate the mechanics of friendship. So here's our class definition, and here is the definition of the setX member function that receives a count reference as its argument, which we're calling C, and an integer called val. And you'll notice here at line 32 that we say c.x to access the private x data member of the count object that c refers to. Now, normally when we try to do that, we get compilation errors if we try to access a piece of private data from a function that's not a member of the same class. However, because setX was declared back up here inside class count as a friend of the class, we are indeed allowed, through our handle to the object of type count, to access the private piece of data directly. So c.x is accessing one count object's x private data and assigning it, in this case, the value that is stored in the parameter val. Now, to prove to you that this works, in main we create a count object called counter. We print its initial value after we instantiate the object or create the object, which of course was 0 by default. Then we call setX, giving it the counter object we wish to modify and the value we wish to place into it. And that, of course, is going to directly access the private data x and assign it 8. And then to prove to you that it worked, we print out the value of the counter object. So if I stop there and run this program, we can see in the output window that counter .x after instantiation was 0, and after the call to the setX friend function, it is now 8. So clearly the friend function, even though it was not considered to be a member of the class, because it was a friend, it was indeed able to use the handle to the count object to modify the private data directly. Now, to demonstrate what happens when we try to access private data that is from a member function that's not a friend of the class, we're going to now look at figure 1016, which is basically the same program. In this case, however, we have the same class count with no friend declaration. And you can see here we have a function called cannot set x, which also receives a reference to a count object and an integer called val. But when we try to directly access the private data here, we get an error message saying that the member x from class count is inaccessible, and that's because it is a private member of the class, and this member function is not declared to be a friend. You, as the designer of a class, get to choose what functions or other classes will be friends of your class. Other class implementers cannot designate themselves as friends of your class. So it's up to the class's designer to determine in advance anything that should be considered a friend of the class. And again, such member functions are generally considered to be tightly coupled with the class, and in most cases they happen to be operator overloading function implementations that cannot be member functions of the class. So when I try to compile this, you can see the error message also being displayed here, indicating that we can't access the private member declared in class count, and the member it's talking about is x on line 31. And if you look at line 31 here, you can see that's where the red squiggly is also appearing in my Visual C++ IDE. So one other thing about the concept of friends, let me pull up the figure 1015 one more time here just to show you what I'm talking about. So when you're declaring friends in a class, because the friend functions are not class members, it doesn't matter where you put the friend declarations throughout the class definition. The only thing that's required is that you don't put them inside the body of one of the class's member functions. So you can put them in the public section, in the private section, outside, as I did here. It doesn't matter because public and private, and as we'll see, a third keyword called protected, don't have any effect on the friend declarations because those functions are not part of the class's interface. They're not part of the class definition. They are just being designated as friends of the class so that the compiler can allow them to access the class's private member through the handle that the function receives as a parameter.